In 2021, NASA's InSight lander recorded a Marsquake so powerful it shouldn't have been possible. Mars is supposed to be geologically dead. That's been the consensus for decades, except the ground just moved. Every few months, something on Mars releases gas that should no longer exist there. The planet has no business producing it. And yet curiosity keeps detecting it, season after season, year after year. Scientists don't know where it's coming from, because for a very long time, we were certain about Mars. Certain in the way you get when the evidence seems overwhelming and nothing contradicts it. By the time our first landers touched down, the picture looked clear. No magnetic field, no active geology, no liquid water, no meaningful atmosphere. A world that had burned out. The conclusion felt obvious, and for decades, almost no one seriously challenged it. That certainty started breaking apart in 2012. Curiosity landed in Gale Crater in August of that year, carrying an instrument called SAM, Sample Analysis at Mars. Its job was to analyze the atmosphere, and within months it began detecting methane. Not constantly. In spikes, sometimes reaching 21 parts per billion, appearing in warmer months and fading when temperatures dropped. On Earth, that concentration would be trivial. On Mars, it's a problem, because methane in the Martian atmosphere breaks down within a few hundred years at most. Ultraviolet radiation from the sun destroys it. Any methane left over from ancient geological activity should have been gone long ago. The fact that it keeps appearing means something is producing it right now. What made this harder to dismiss was the pattern. The spikes weren't random. They correlated with the Martian summer, appearing when temperatures rose, fading when they dropped. That kind of seasonal rhythm doesn't look like instrument noise. It looks like a process. In 2024, researchers proposed a simpler explanation. The methane might be released by surface heat, or even by the pressure of the rover itself. A mechanical artifact, not a planetary signal. Except orbital measurements show methane fluctuations the rover explanation cannot account for. The instrument is questioned. The source is still unknown. There are two explanations, and neither one is comfortable. The first is geological, serpentinization, where water reacts with subsurface rocks and releases methane as a byproduct. That requires liquid water underground and active chemistry. Neither belongs on a dead planet. The second is biological. Scientists aren't claiming that, but they're not ruling it out because the data won't let them. The methane is real. The source is unknown. And that gap between observation and explanation is exactly where this story gets difficult. Then the ground started moving. InSight landed in November 2018, carrying the most sensitive seismometer ever placed on another world, built by a team at the Institut de Physique du Globe de Paris. For the first months, it heard almost nothing. Then small quakes, then larger ones. In May 2022, it recorded a magnitude 5 event, the largest Marsquake ever measured. It came from Cerberus fossae, a system of deep fractures in the Martian crust that formed less than 10 million years ago. In geological terms, that's recent. Bruce Bannett, InSight's principal investigator at NASA's Jet Propulsion Laboratory, called it really big. What the data implies is that it shouldn't have happened at all on a planet we classified as geologically dead. Cerberus fossae isn't a minor detail. It stretches roughly 1,000 kilometers across the Martian surface. Some sections show signs of lava flows that geologists estimate occurred within the last 2 to 3 million years. There are places on Mars that were volcanically active more recently than our earliest human ancestors walked the Earth. The seismic data also gave scientists something they had never had before, a real look inside Mars. The crust turned out thicker than expected, the mantle warmer in places than the models predicted. The planet's interior is not the cold, inert shell the dead world picture assumed. Something down there is still moving, and InSight spent 4 years listening to it before the mission ended in December 2022, its solar panels buried under Martian dust. Then came the radar, In 2018, a team led by Roberto Orossi at the National Institute for Astrophysics in Bologna published results from ESA's Mars Express spacecraft, which had been orbiting Mars since 2003. They had been analyzing data from an instrument called MARSIS, a radar that sends radio waves through the surface and reads what returns. Buried 1.5 kilometers beneath the southern polar ice cap, the signal came back with a reflection pattern consistent with liquid water. A lake roughly 20 kilometers across, sitting in permanent darkness beneath 1.5 kilometers of ice. At an estimated temperature of -68 degrees Celsius, water has no business being liquid. But under sufficient pressure, with a high enough concentration of dissolved salts, it can stay that way. We know this because it happens beneath the ice sheets of Antarctica. And in those subglacial lakes, life survives. Other researchers have disputed the reading. Some argue the signal could come from clay-rich sediment or CO2 ice rather than liquid water. Orossi's team maintains their interpretation. The disagreement is ongoing, and nobody has proven this away. What matters is that serious scientists are still arguing about it years later, which means the question remains open. Mars Reconnaissance Orbiter added yet another layer. For years, its high-rise camera photographed dark streaks appearing on Martian slopes during warmer seasons and fading when temperatures dropped. The early leading hypothesis was briny liquid water trickling down hillsides. Later studies suggested dry granular flows instead. The debate is unresolved. But the surface of Mars is doing something seasonal, something that changes with temperature, and we still cannot fully explain it. In 1877, Giovanni Schiaparelli pointed his telescope at Mars and drew dark lines he called canali. Mistranslated as canals, it was later seized upon by the American astronomer Percival Lowell, who spent years mapping what he believed were artificial waterways built by a dying civilization. The science was wrong, but over 400 years of telescopic observation, the assumption that hardened, that Mars was dead, inert, finished, became one of the most confident conclusions in planetary science. That assumption is now being challenged on multiple fronts simultaneously. By methane that keeps reappearing on a planet where it shouldn't exist. By quakes from an interior we assumed had gone cold billions of years ago. By dark streaks on hillsides that move with the seasons and still have no agreed explanation. By a radar signal buried 1.5 kilometers beneath the southern pole, pointing to something liquid in the dark. If that interpretation is correct, Mars may still contain environments capable of supporting life today. Not billions of years ago. Now.